heart divisions, what we call heart septation. That means there is septal formation within the common chambers of the heart. From the previous lecture, we have made mention that the heart, finally after the U looping and the S looping, the heart has two common chambers, what we call the common atrium and the common ventricle. These are the two major chambers of the heart that are common to it. And so by the time these two common chambers are formed, each of the chamber, either the atrium or the ventricle, is going to be divided into two, so that at the end you have four chambers. So you have two chambers in the atrium, left and the right. You also have two chambers with regard to the ventricle, left and the right ventricles. So all this septation or divisions of these chambers do also take place concurrently as the heart continues to develop within the third week of the intrauterine life. So the atrial septum begins to develop by the time we have some growth coming at the edges of what we call the atrioventricular canal. If you can remember what we were discussing in the previous lecture, between the atrium and the ventricle, we mentioned a canal, what we call atrioventricular canal, and which is this canal here. So from the common atrium to the common ventricle, there is this AV canal. So from the edge of this AV canal, if this is the anterior aspect of the heart, and this is the posterior aspect of the heart, so from the posterior side of, and from the anterior side and the posterior side of each of this opening, you have growth coming. So you have an anterior growth, you have a posterior growth. And this growth, they continue to approach each other. And this growth is what we call endocardial cushions. So you have endocardial cushion coming from the posterior side of the AV canal, and then you have another endocardial cushion coming from the anterior side of the AV canal. So the two together, they tend to come closer to each other until they meet in the middle line. So if you now cut a cross section like this, you take a cross section and then you look at it from above, this is what you are going to see. So this is, let's say, the anterior side, this is the posterior side. So you will see that you have anterior endocardial cushion, you have posterior endocardial cushion. So they tend to approach each other until they finally unite. So that by dividing this AV canal into two canals, so you have the left part of the AV canal, you have the right part of the AV canal. So the atrioventricular canal is now being divided by two endocardial cushions, one anterior, one posterior. They unite in the midline so that they divide the common AV canal into two parts, left side and the right side. So by the time you now take a cross section like this of the heart, and then you look at it from this side, this is what you are going to see. So by the time you now cut across this endocardial cushion, now since the two cushions unite, they now form something like a partitioning the common atrioventricular canal into two. So this cushion is now called intermediate septum. So the two cushions, after uniting together, they are now called intermediate septum. So by the time you now cut across the septum like this, you are going to look at it from this side, you are going to see this. So you are now going to cut across the intermediate septum, and so the intermediate septum now is the beginning of the formation of the atrial septum. So now the atrial septum begins to develop by the time from the roof of the common atrium. Septum begins to develop and start coming down until it approaches the intermediate septum or the endocardial cushion. So as it approaches the intermediate septum, it leaves a small opening. That small opening is what we call ostium primum. We call it what? Ostium primum. So this ostium primum can also be called foramen primum. Foramen what? Foramen primum or ostium primum. So this ostium primum is a gap between the developing septum primum and the intermediate septum. So this foramen that is now been, this opening that is now been left is to allow blood as it comes from the venous end, from the venous end to enter into the left atrium. If we assume that this is the right side of the heart and this is the left side of the heart, so blood from the right side of the heart, developing heart, passes into the left side of the developing heart, so that it will now circulate from the left side of the heart, and then it goes into the developing embryo, body of the developing embryo. So finally, this septum primum, as it descends from the roof of the common atrium, it approaches towards the endocardial cushion or the intermediate septum, thereby leaving this opening, known as ostium primum or foramen primum. So it finally closes this opening, so much so that there will be no more opening. So if that's the case, blood cannot from the right side go into the left side. Are you clear from this atrial area? Are you clear? So for the blood to be able to pass from the right side into the left side from this upper chamber, there has to be some opening here. So from the upper part of this septum primum, some spaces, lacunae, also tend to develop at the upper part of the septum primum. And finally, these lacunae, they tend to coalesce together until they form a small foramen here as the upper part of the septum primum. You get it? So that here you have an opening here, what you call ostium secundum or foramen secundum. So you can either call it foramen secundum or ostium secundum. So I told you initially that this ostium primum is being closed. You get it? And so what happens is that there is a contribution from the intermediate septum. You know, if you can remember, we said this endocardial cushion, after they unite together, they are now called intermediate septum. So to close this ostium primum, which is this one, there is contribution from this intermediate septum to close this ostium primum. So also, there is also growth from the lower part of the septum primum, so that at the end, this ostium primum is being blocked. While it is being blocked, as it is blocking, another foramen is forming above. Are you clear? This one is being blocked, another one is being formed above. So finally, you have this ostium secundum. Are you clear? Or foramen secundum. So that blood can now pass from this right side, goes into the left side. So that is it. So by the time this foramen secundum is being formed, you also have another septum getting developed from the right side here in the right side of the common atrium. So you have another septum getting developed, so also dropping down from the upper part of from the roof of the atrium itself. This septum as it's dropping down is the second septum. And so that is why it is called septum secundum. Septum what? Septum secundum. So it is now the second septum. The first one is septum primum. That is primary septum. First septum. So now you have the second septum dropping down from the right side of this septum primum. And this is what we call septum secundum. So as this one is dropping down also, it is short of meeting the intermediate septum. So much so that there is a gap between the septum secundum and the septum primum, so that blood can still pass from the right side of the heart, passes below the inferior border of the septum secundum, and then passes upward, and then pass through the septum, through the ostium primum, ostium secundum into the left atrium. Are you clear? This foramen that is now formed between the lower border or lower margin of the septum secundum and the septum primum, this is what we call foramen ovale. We call it what? Foramen ovale, or some they call it foramen ovale. Depends on what you decide to call it. But then actually the pronunciation is foramen ovale. So you have a foramen ovale, given chance for blood to pass from the right side of the heart between the septum secundum and the septum primum, so that the blood can now pass into the left atrium. Now we've seen that there are two septae, singular septum, plural septae. You get it? So now we've seen that there are two septae forming to divide the common atrium. Septum primum in green, septum secundum in blue. And if you can remember, we said that there is an addition coming from the intermediate septum to close this ostium primum. Are you clear? So now, how many septae have you seen here in the middle line to give rise to these two separate atrium? Now we have seen septum primum, we have seen septum secundum, we have seen intermediate septum, also given contribution to block this ostium primum. So we have about 4 contributions now. Are you clear? Septum primum, septum secundum, intermediate septum, and the contribution from the intermediate septum to close the ostium primum. So we now have 4 contributions in the middle line to give this 4 septae. Are you clear? Now, there is also, if you can remember our last lecture, we talked about the absorption of the horns of the sinus venosus. This sinus venosus, if we try to draw the sinus venosus like this, so if this is the right horn and this is the left horn, we made mention that this right one, get absorbed. You get it into the atrium. You get it. So also on this side, the left one also get absorbed. And so we now said that the two horns, both the left and the right, they get absorbed into the atrium itself, common atrium. But finally, this canal here, of the two horns getting into the sinus venosus here, so by the time they get absorbed into the common atrium towards the right side where the right atrium is going to develop, there is thickening of this canal here between the sinus venosus and the two horns, so that you have what you call right and the left venous valves. So they form something like a valve, venous valves, so that you have one on the left side, you have one on the right side. This left venous valve also contribute to the septation of this interatrial, septation we're talking about. So again, similarly, there is another septum dropping from the right side of the septum secundum, and this septum this time around is called septum superior. So the septum superior that attaches to the left and the right venous valve is also contributes to the septation of the common atrium. So we can say finally that the septum, the interatrial septum, is mainly formed from number 1, septum primum, number 2, septum secundum, number 3, intermediate septum, number 4, contribution from the intermediate septum to close the ostium primum, number 5, left venous valve from the absorption of the sinus venosus, and also the septum superior developing from the right side of the septum secundum. Are you clear? So these are the combination of structures that are combined together to form the interatrial septum. How does this septum now close? You see, by the time the heart continues to develop, the blood continues to go from the right atrium, now being formed because of these structures here in the midline. It will now pass through this foramen ovale that I have made mention. It passes upward and then passes into the ostium secundum before it finally reaches the left atrium. But by the time the embryo, the developing fetus during birth, this will continue to be like that up to the time when the baby is going to be born. That means from the time when the heart is fully formed, that is by the 4th week of intrauterine life, heart is beating already. So by the 2nd month, heart is fully formed. And so by the time the baby is now born, lungs have already been formed that time. Blood will now start going into the lungs. And so as the blood is now coming from the lungs into the heart, the pressure initially was higher in the right side of the heart than in the left side. And that is why blood is able to pass from the right into the left. But after birth, the reverse is the case, so that the pressure in the left side is higher than in the right side. So as soon as the baby cries, the first cry of the baby, this septum superior, septum primum is now the blood from this side of the left side of the heart. It will now push this septum primum over the septum secundum so that they become glued together. They become fused together so that there will be no more gap, so that blood cannot go from the right into the left. So it is that first cry of the baby when the blood now comes from the lungs, enters into the left atrium. The blood now pushes the septum superior over the septum secundum so that the two septae, they become merged together. So there's a merger between the septum primum and the septum secundum, so that you have a complete collision between the right and the left. So this septum is now being formed. So we have now seen the components of the interatrial septum. So what you should get to know is that the septum primum is crescenteric in shape. From this diagram you can see the way I try to draw it is crescenteric. Here the lower edge or the lower border is crescenteric. If this is a posterior part and this is the anterior part, so this septum primum has anterior horn and posterior horn. And so the two horns, each of these two horns now touches the endocardial cushion. So the posterior horn touches the endocardial cushion, the anterior horn also touches, so that it leaves a space in between, which is now going to be filled by contribution from the endocardial cushion. Similarly, the septum secundum is also crescenteric. Now I have taken a cross section like this, and then I look at it from this side, and this is what I just tried to draw. So even this septum secundum, it is crescenteric in that it has an anterior horn, it has a posterior horn. The posterior horn is short of touching the intermediate septum, while the anterior horn touches the intermediate septum. So that it now leaves this wide gap here. This is the foramen ovale here, around here. This one I have already discussed. So now we've seen this. So we'll now discuss the interatrial septal defect. So we just have a break before I finally discuss about the interatrial septal defect.